Okay. For the first example, we got this polynomial here, x squared minus x minus 12. We want to go ahead and find all the possible zeros, meaning we're going to have to go ahead and find this right here, the p and the q, meaning the factors of p, the factors of p are the values here. I'm really struggling here. The values here. For 12 would be our ending coefficient, which we see as p. Our q's, on the other hand, are going to be our factors of this term right here in front of the leading degree. So this is what we're going to do. We're going to label p as 12. And the reason we don't care about this little negative sign right here is because at the end of the day, it's positive and negative. And our q is going to be the term right here in front of the x squared, our leading term, which is 1. We're going to go ahead and break down these factors. So what numbers multiply to 12? Well, that's 1 and 12. And then we have 3 times 4, and also 2 and times 6. So we have all of that. Now for 1, we're going to find the factors that equal to 1. Well, that's just 1. Okay, from here, we're going to go ahead and find the term p, all the terms p, divided by q in a positive and negative values, because both of them equal. So negative 1 times negative 1 is still equal to 1, and 1 times 1 is still equal to 1. That's why we have a positive and negative. Okay, so let's begin. So our plus or minus p over q gives us that this will be 1 over 1, 3 over 1, 2 over 1, 4 over 1, 6 over 1, 12 over 1. So it's really it's just 1, 2, 3, 4, 6, and 12. Now we can't forget that these are positive and negative, both of these right here. Okay, so in reality we have 1, 2, 3, 4, 5, 6 positive real zeros, and we have 6 negative real zeros. So we have a total of 12 possible zeros. Now, considering what we learned from polynomial degrees, this polynomial has a degree of 2. This 2 tells me that the degree is equal to 2. So that means degree is equal to amount of total zeros. Okay, so in reality we have 12 possibilities, but where only 2 are real, meaning they could be both positive or both negative or even imaginary. So there, as long as there is 2. Okay, now the next part is using these factors, and we're going to go ahead and use synthetic division to check which one of these actually works. Well, we have all of these in total, and it's going to be a little bit hard to decide which one works. Well, I know this right here. I know that this right here is factorable. So x squared. X squared. I'm struggling here. X squared minus x minus 12. Minus x minus 12. I can go ahead and use the tabular method, or I can go ahead and pick 2 factors right here. Well, x times x. They go ahead and multiply to negative 12. So I got a 4 and a 3, and when I add them, they must be negative. So it must be negative on the larger number. So our function can go ahead and be factored by x plus 3, x minus 4. Meaning our zeros are each term right here set equal to 0, and x minus 4 is equal to 0. So we have this right here, x is equal to negative 3 is a possibility, and x equals 4 is a possibility, which are our real zeros. And if we go ahead and check over here, the numbers that we had, positive 4 and -3 are a possibility, which work. Now, if we weren't able to factor, that means you're going to go ahead and have to use your knowledge of the P's and Q's and use synthetic division to go ahead and check if these are roots. So, since we know these are factors, -3 is a factor, so we're going to go ahead and do synthetic division to prove that they are factors. What's going on? Okay, so we're going to use synthetic division, so -3, and then I'm going to go ahead and use synthetic division. This is 1, this is -1, and this is -12. From here, I bring down the 1, this gives me 1, -3 times 1 gives me a -3. I add them together, that get a -4. I multiply them together, I get a -3 times a, what did I do? Undo. And I go ahead and continue. You multiply them together, you get a +12. Add them, you get a factor of 0. The remainder tells me that it is equal to 0, so I have that it is a factor. Okay, now using what we know, we have 1 minus 4 equals 0. This term right here is also a factor. Now, what I have to remind you is that this degree was eventually x squared, so when we did synthetic division, this changed this right here to be x minus 4, where the 1 we don't have to write it since it's just a coefficient. Since this is a factor, we can set x minus 4 equal to 0. We do some algebra, so add 4, x is equal to 4 is our other 0, confirming what we just found over here. So there's two methods. We go ahead and factor, or you can use synthetic division. Keep that in mind. As you get the degree to be higher, you will have to rely more on your guessing and checking. Then check synthetic division. If the remainder is 0, then you do have a factor, means you can continue from here. Thank you. Bye.